Next topic, please write. Nucleophilic substitution reactions are of two types. First one was SN2I taught you in the previous class. The next is basically substitution nucleophilic unimolecular that is known as SN1 reaction. The previous one was bimolecular and this is uni. Please write with me. SN1 reactions are carried out in polar protic solvent. Polar, you know that charged polar protic solvents. Like pure polar protic solvent, that means that gives H plus, like for example water, alcohol we can take, acetic acid, etc. These are all polar protic solvent. Now see, previous reaction was held in one state. That means basically reaction, but this is SN1 is two-step reaction. This is a step two-step reaction. If we are going to, first of all, I'm going to write the reaction CH3 whole thrice CBr, and if you are going to react this with a nucleophile like OH minus, so what happens here? This will replace the OH minus will replace Br and Br minus will eliminate it. Now, if you're going to write the nomenclature of this, you take so this will be this propane. I'm going to explain the mechanism also. First write it, and its name will be 2-methyl propane 2-ol. So please write this reaction. This is SN1 reaction, but this reaction takes place in two states, and that I am going to explain. Wait a minute.
Are you liking? I don't cut.
Let me know when you are done with this. Everyone done with this? Very good, Sneha.
No, sir.
Nafisa and
Still
Hamza,
waiting.
I'm waiting for you. Okay. Okay.
Yes, sir. Finish.
Hamza, are you done with this?
Yes, sir.
Now see, mechanism, if we are going for mechanism, you can see CH3 whole thrice CBr. This is the first step. Step 1. And what happens here? It's basically this Br will take the electron from carbon and it will be eliminated from this. So it will be like Br minus because it gained electron from carbon. Now this carbon will have 3 CH3 group and there will be positive charge. That means this is carbocation. Now this is the first step. Now second step is basically this carbocation will be attacked by that nucleophile OH minus, and this will basically attack this, and it is a step 2 reaction. This is a step 2, and it will attach with this. That means CH3 whole thrice COH. Now the important point is that since carbocation formation takes place, that's why reactivity will be 3 degree tertiary, then 2 degree, and then 1 degree. Always remember. It is very important, the first point. And second point is that it is two-step reaction. It's two-step reaction. SN2 is single step reaction, and this is two-step reaction, double step reaction. In the first step, there will be the formation of carbocation, and in the second step, there will be attack of nucleophile on carbocation. Got it?
Yes, sir.
Very good. Please write it. Let me know when you are done with this.
Yes, sir. Finish.
Very good. Sneha, are you done with this? Very good. Hamza? No. Allylic and benzylic are allylic and benzylic halide. Show high reactivity, high reactivity towards SN, towards SN1 reaction. Why does it so? Because there is resonance. Because we can write another point for this. Basically, allylic, you know that what is allylic, there will be double bond. And then there will be like this. This is allylic. What is benzylic? There will be benzene. And then CH2. X, this is benzene. So basically, allylic and benzylic halides show high reactivity towards SN1 reaction because carbocation thus formed gets stabilized through resonance. Now you can see if we have CH2 double bond, CH, and then CH2X. What happens here? This will go. So what we will have now, CH2 double bond CH, and here it will be CH2 positive carbocation, and this carbocation will be stabilized by a resonance. Now it will be CH2 plus and then CH and then double bond, delocalization of pi bond will take place. That's why this allylic will be more reactive. In the same way, you can go for benzylic. Benzylic will have a structure like this. And again, if X will get electron from carbon, what we will have, you can see CH2 plus, CH2 plus. Now it will have resonance like this. And again, you can see if this bond will be broken and go to this carbon, this will be like this, and this will have positive charge. Have you done a resonating structure in class 11? In the same way, like this. So again, the carbocation will come to this carbon, and there will be double bond, and here it is double. Again, so you can see now there is positive charge, double bond is here, double bond is here, and double bond is here. Again, this will come here. So double bond, there is delocalization of pi bond, CH2 plus. So due to this through resonance, it gets stabilized. That's why it is more reactive towards SN1. Okay. Very good. Let me know when everyone done with this. Done.
Yes, sir.
Very good. Now, so it's important to note that the reactivity series for SN1 it is 3 degree, 2 degree, 1 degree, and for SN2 it is 1 degree, 2 degree, and 3 degree. It is in decreasing order that I am telling you. Now, the next point is that I already told you about the best living group. So first of all, I'm going to write again the for SN2 reaction. In this direction, the reactivity increasing. So I'm going to write first tertiary halide for SN2, tertiary halide, then secondary halide, and then primary halide, and then super primary like directly X car connecting to this, because it will have the less steric hindrance. Steric hindrance increases from right to left. That's why reactivity towards SN2 decreases. Now for SN1, for SN1 reaction, you can write tertiary halide is the most, then secondary halide, primary halide, and then CH3X. Please write it. And next point, which is very important, for a given alkyl halide is common or same for a given alkyl halide. The reactivity of the halide Rx follows. Basically, R is common, so best living group is iodine. So it will have the highest reactivity, then bromine, and then chlorine, and then fluorine. Let me know when you are done with this. Very good. Nafisa, are you done with this?
Yes, sir. Finish.
Okay, please do it and let me know. Finished. Hamza. Okay. So let's move to the question for reactivity series. You can see first write the question. Order of reactivity of the following compounds in SN1 and SN2. In SN1 and SN2. The first question is basically the four isomeric bromobutane. There is a hint that means a bromobutane will have four isomeric structure isomers. So please write the isomers of bromobutane and then arrange them in increasing or decreasing order of reactivity towards SN1 as
Sir, the first one is 1-bromobutane.
one bromo. What? Please arrange all in order of SN1 and then answer me.
Okay, sir.
Hamza, is there any answer from you, Sneha? And if you don't know the answer, unable to solve it, please let me know. I will explain. So, Sneha, SN1, which one will be first of all, what is the isomers of bromobutane? So I can write the isomers of bromobutane as this 2 CH2 CH2Br. The second one is CH3 whole twice. The third one is CH3 CH2 CHBr CH3, and the fourth one is Br CH3 CH3 and CH3. I'm going to write it also in the same way. Like this will have CH3 and a CH3. Now you can see this is 1 degree. This is also 1 degree. This is 2 degree and this is 3 degree. And I'm going to do it for SN1. So in SN1, 3 degree will be more than 2 degree. Now decide this 1 degree and 2 degree. You can see since here carbocation will form. So only one group is there. It will go like this. But if carbocation will form here, it can gain from here, here and here. That means basically branches are there. Branches are more there. That's why it is more reactive towards SN1 than SN2. Are you getting my point? And for SN2, it will be opposite. For SN2, it will be opposite. This will have the maximum reactivity because it is less steric hindrance. Got it?
Yes, sir.
Please do it.
Yes, sir. Finish.
Hamza, are you done with this?
Yes, sir.
Very good. Now the next question. I just switched off my video because there is problem in Wi-Fi. It is slow. Will that be okay for all of you?
Yes, sir. It's fine.
Thank you. Now see, we have another question for this reactivity, and these questions are very important. You need to arrange this in order of reactivity. C6H5 CH2Br. Then the second is C6H5 CH C6H5 Br. Then the third one is, you need to write the structure of this compound, then you will come to understand what is this. And if you have any doubt regarding this, please ask me. Please write the structure, then we will talk about it. Please let me know if you are unable to solve it.
Yes, sir. Finish.
Finished. So can you tell me the highest reactivity towards SN1 in these compounds? The most reactive.
C6H5CH bracket
First one,
C6.
second one, third one,
Second
fourth
one.
one.
Second one.
You don't need to second one. Okay, this is wrong. For SN1, if I'm going to write the structure, you can see this is our benzene. This is CH2Br. Therefore, second one, you can see there is also benzene. And this is Br. And for the third one, you can see there is CH and then CH3. And here it is bromine. And for the last one, you can see CH3. And here it is also benzene and bromine. Now, after removing if I'm going to talk about carbocation, sorry, SN1, there will be the formation of carbocation. So I'm going to write the structure of carbocation 2. Now you can see there will be CH2 plus, and this carbocation will be in resonance. Also, if we are going to talk about this will have plus, and this will also be in resonance here and here also. That means this is more stable, so it is more reactive than this. Again, if you are going to talk about this, so you can see CH plus and CH3. There will be two effect, inductive effect. That means this will donate some electron to stabilize it, and there will be sorry, I just wrote the wrong arrow in this and this also. Since carbocation is electron deficient, so there will be resonance like this, and there will be resonance like this. Now see, for the third one, you can see C plus and here CH. Now you can see there is two resonance. Wait a minute, arrow is opposite. There is two resonance as well as plus I inductive effect. So if I'm going to write this A, B, C, D, which one will be more stable carbocation? D will be more stable carbocation. So it will have the highest reactivity towards SN1. Now for SN2, you can go for where is 2 benzene? This, because it has also two side resonance. So this will be B. Now, if you are going to talk about this and this, you can see there is support of inductive effect also. There is only resonance. There is resonance as well as inductive effect. So C and then A. Got it, Nafisa?
Yes, sir. Okay.
And what will be for SN2 opposite of this?
Yes, sir. Finish.
Hamza and Sneha, please do this for SN2. SN2 is very easy. For SN2, A will have highest, then C, then B, then D. Okay, this will have the highest because it is less steric hindrance than this, then this, then this. Please write it and again let me know. Very good. Hamza, you are also done with this.
Yes, sir.
Very good. Now we are going to talk about isomerism, or we write a topic that is stereochemistry, or we can write stereochemical aspects of nucleophilic substitution reaction. The stereochemical aspects of nucleophilic substitution reaction. Basically, here we are going to discuss about the optical active compound or optically inactive compound. And for that, we need to do an experiment. Now see, we are going to pass some unpolarized light. This is unpolarized light. First, focus on this. This is unpolarized light, and going to pass through a polarizer. This is basically polarizer. This is polarizer, an instrument that makes unpolarized light polarizer. So if you can see unpolarized light passing through polarizer, now this light becomes polarized light. This light becomes polarized light. Polarized light. And here you are going to put the substance or the compound. You are going to check whether this compound is optically active or not. If it is optically active, or is it optically active or is it optically inactive? So there will be analyzer. After this is analyzer, which will show you whether this compound or substance is optically active or not. If it is optically active, then this light will rotate either in clockwise, this is anti-clockwise, or either in this is anti-clockwise, either in anti-clockwise or either in clockwise. If the substance not rotating, if this light not rotating, that means the compound is optically inactive. Optically inactive. So it's very easy to understand. You are going to pass unpolarized light through a polarizer, which will make the light polarized. And after polarizer, there will be substance that we are, or the compound, we are going to check whether this substance is optically active or not. So after passing this light through this substance, there will be analyzer which tells you whether this compound is optically active or not. So this light will pass through this also. either this light will rotate. If it will rotate, then it is optically active, and if it will not rotate, that means it is optically inactive. In this case, first and last, this is optically active case, optically active compound, optically active. Okay, now if it is rotating clockwise, that means dextro-rotatory. Dextro-rotatory. This is dextro-rotatory, that we denote it with D or plus sign. And if it is rotating anti-clockwise, that means levo-rotate. That means levo-rotatory, and it is denoted with L, a small l, or we determine whether a compound is optically active or not. Got it?
Yes, sir.
Please write it.
Sir, if it's anti-clockwise, what's the name again? Devo.
Dextro-rotatory.
Oh, the
Dextro-rotatory.
anti-clockwise.
Anti-clockwise is levo-rotatory. L-A-E. I'm going. Wait a minute. L or minus. Are you done with this?
Yes, sir, finish.
Okay, take your time, Sneha. Hamza, are you done with this? Very good, Sneha. Nafisa,
Yes, sir. Finish.
done? Finished. Very good.
Yes. Yes, sir. Yes.
There will be some terms which you have to take, you have to remember, like chiral and achiral. So for chirality, achiral is basically opposite of chiral. Chirality, carbon should be hybridized, and this should be or must be attached with four different groups, not same group, four different. Any of this one point will be violated by a chiral compound, whether it should be it will be not sp3 hybridized, or you can say it will not be attached with four different chiral or this and this. Which one is chiral and which one is achiral?
Sir, the second one is chiral, and the first.
This is chiral. Now see, if you are going to check this carbon, this will have three hydrogen and not basically carbon should not have same group, so it is not chiral here. If you are going to this check this carbon, this will have two hydrogen same, so this will also not chiral carbon. If you are going to check this carbon, this will have three hydrogen which are same, so this carbon will not be will also not be basically chiral. Now when you talk about this, you can see this is different group, this is different group, this hydrogen is different group, and this is also different group. So this carbon, or since it is chiral, so this carbon is chiral compound. And if you are going to talk about this is not chiral carbon, this is also not carbon, this is also not chiral carbon, this. Now when you talk about this, you can see this and this group are same or not, this or this. Tell me, Nafisha.
It's the same.
Nafisha, are you there?
Yes, sir. I'm here. It's the same.
Same. So it is not chiral, that means achiral it is.
Sir, can you explain again? I didn't understand. Sir,
Done.
sir, can you explain again? Like, Why
Which one?
that's
First
this
one or
a
second?
chiral? Why
Okay, now
that's
see.
chiral?
Okay. Now, can you tell me, or whatever I'm asking? This carbon will have three hydrogen. Yes or no?
Yes, sir.
Same group. That means it is not chiral. This carbon will have two hydrogen. Same. It is also not chiral. This carbon will also have same three hydrogen. Same group. That means it is not. When you are going to talk about this carbon, it will have one hydrogen. Now see, this is CH3 and this is C2H5, different
Yes, sir.
group. This is Br, different group. This is hydrogen, different group. That's why it is chiral. Are you getting my point?
Yes, sir. Okay.
Now, now come to this. This carbon will have three hydrogen. That's why it is not chiral. This is also not chiral. This is also not chiral. This is also not chiral. Now, if you are going to think about this, this is C2H5. This is also C2H5. Same group. Yes or no?
Yes, sir.
According for this carbon, this and this are same group. That means a chiral. Chiral, how we defined chiral? A carbon should be sp3 hybridized and it should be surrounded by four different groups.
Yes, sir. Okay.
Please write it and let me know.
Yes, sir.
Done. Now see, we have another term which is known as enantiomer. Enantiomers. So first of all, I'm going to define what is enantiomers. The stereoisomers are related to each other as non-superimposable, as non-superimposable mirror image. Are called enantiomers. So it's very easy to understand the compound. If you have a compound, you are going to take mirror image of that, and if this the compound and the mirror image are not superimposable to each other, that means they are enantiomers. Are you getting my point? Like if we have, please focus here. If we have CH3 H CH3 OH and this is our mirror, then what happens? This will left will go to right, right will go to left. Yes or no? OH will be
Yes, sir.
here and this will be on the right hand side, CH3. Again this will be on right hand side, CH3, and here will be H. This is mirror image basically, and if you are going to rotate this by 180 degree, you will get the same compound. You will get the same compound. This is CH3, this is CH3, and this is H. So basically this and this compound is superimposable. That means they are not mirror image of each other. A, B, C. If you are going to rotate B by 180 degree, C is obtained and C is superimposable. Superimposable. Okay, first of all, impossible. Wait a minute. I want to ask a question whether this compound impossible. whether this, let me know, this compound is chiral or off-chiral.
Sir, it's chiral.
It's not chiral. You can see this is carbon, this is CH3, this is CH3, same group on same carbon.
Oh, okay. Yes, sir.
Or chiral.
Yes, sir.
Please write this, and then we are going to take another compound for mirror image, and then you will see it will be chiral and it will be non-superimposable. The mirror image will be non-superimposed.
Yes, sir. Finish.
Sneha, are you done with this? Okay, please write it and let me know. Sneha, are you done with this? Very good. Now, if you are going to take mirror image of butane 2-ol, butane 2-ol. Now see, I am writing this compound in 3D structure. Now, if we are going to take this is mirror. This is basically mirror image of butane 2-ol. And if you are going to rotate this compound mirror image, you will get a compound like this. See, what is the difference? This is this C2H5 will come here and CH3 will be switched to there here and H will be here. Now you can see this is rotated mirror, rotated mirror image. So please write it F. I'm going to take this D, E, and F, and you can see there is C2H5 dashed, and this is also dashed. So F is not, or F is non-superimposable mirror. Superimposable on its mirror image D. And now tell me whether this is chiral or not.
Yes, sir, it's chiral.
It's chiral. Very good. Everyone done with this?
Yes, sir.
Very good. Now see, I'm going to give you a question. Identify chiral and achiral molecules in each of the following pair of compounds. So the first one is this is CH3. The second one is the third one is whether in 1, 2, and 3, which one is chiral and which one is achiral.
Sir, in the first one, the second one is chiral, and then the first one is achiral.
You are lagging. This is chiral, right? This is not.
Yes.
This is achiral,
Yes, sir.
right?
Yes, sir.
Now tell me
Yes, sir,
about the
yes.
second question.
The second question, the first one is achiral, and then the second one is chiral.
Achiral, right?
Sir, how is the first one chiral? Isn't CH3 in both?
Now see, only if you are going for this carbon is attached with CH3, OH, and H, and this carbon
Yes,
is
sir.
attached with this C2, C3H7. No?
Yes, sir.
This is attached with this group, so this is different than this because this is only
Okay.
CH3,
Okay, yes, sir.
and this is three carbon.
Yes, sir.
Hmm.
Sir, the third one, the second one is the second
The
one
second
is
one is,
a chiral, and then the first one is chiral.
yes, this is Br, this is CH3, this is another group,
Yes,
this is
sir.
hydrogen is another. So it's chiral, this is achiral. It's very easy to understand. Yes or no?
Yes, sir.
Now I'm going to give you another question. Wait a minute. And Hamza, please answer me.
Yes, sir.
Yes.
Sir, the first one is CH3I.
Wait a minute. Wait a minute. Is there any answer from Sneha and Hamza? Very good, because both are 1 degree. And for SN to 1 degree, 2 degree, 3 degree follows, but I is more good living region, best living region, so this will be. And for second,
CCl, CH3, CCl.
which one is first or second?
First
Very
one.
good. This is 1 degree, this is 3 degree. So this will be, because for SN to 1 degree is more reactive than 2 degree.
Yes, sir. Yes, sir.
So this will be your answer. Okay.
Yes, sir.
Okay. So in the next class, you are going to read about this chemical properties. Wait a minute. We are almost done with the chemical properties. Basically, nucleophilic substitution reaction. In the next class, we are going for reaction with metal, as well as elimination reaction and Grignard reaction. Grignard reagent. Then reaction for basically in class tomorrow. Class. Okay. Tomorrow's class. I'll see you in the next
Yes,
class.
sir. Thank you, sir.
Okay. Thank
Thank you,
you.
sir.
Thank you, everyone.
Assalamu alaikum.